Hello everybody and welcome. My name is Mr. Cantor and this is Modeling with Mr. Cantor. Now today we're going to be looking at Explore Part B. What I want you to do first is to please read the story to yourself and then we will read it together. Alright, welcome back. Let's read the story together. It says, Andre and Noah joined Elena, Jada, and Lynn in recording their basketball scores. They all recorded their scores in the same way. The number of baskets made out of 10 attempts. Each collected 12 data points. Andre's mean number of baskets was 5.25, and his MAD was 2.6. Noah's mean number of baskets was also 5.25, but his MAD was 1. Here are two dot plots that represent the two data sets. The triangle indicates the location of the mean. Now, before we move on, one of the things that you might have noticed is that the two bullet points contain the word MAD. What does MAD stand for? Please pause this video and let me know. Alright, welcome back. If you said that MAD stands for mean absolute deviation, then you are correct. And we're going to talk more about that momentarily. Alright, let's move forward. Let's take a look at Part A. Please pause this video, read Part A to yourself, think about it, and then we will talk about it together. Alright, welcome back. Part A says, without calculating, decide which dot plot represents Andre's data and which represents Noah's. Explain how you know. Alright, so what I want you to do is to look at both of these dot plots, pause the video, and think to yourself, which one do you think matches which basketball player? Alright, welcome back. If you said that since Noah's mean absolute deviation is 1, that means that his data should be closer spaced. If you look at data set B, you will see that the dots are more spaced apart than in data set A. This means that Noah's data set is A and Andre's is set B. So let's take a closer look. At data set A, we can see that the mean is where this triangle is located. And you can see that the majority of the points are very, very close to that triangle. However, we can see in data set B that where the triangle is, there is a significant amount of space on the left side of the triangle to where the rest of the data points are. You can see also that the data points range all the way to 9, and to the left they range all the way to 1. Whereas in data set A, the furthest reach we have on the left is to 3, and the furthest reach to the right we have is 8. So, since Andre's MAD is 2.6, that means that his mean absolute deviation is 2.6. So on average, his points are 2.6 spaces apart from the mean, whereas Noah's points are about 1 space away from the mean. So since Noah's MAD is smaller, that means that Noah's data set is closely clustered together, which is saying that Noah's data set is definitely A, and Andre's data set is most likely B. All right, with that said, let's look at the next question. Please pause the video, read the next question to yourself, and then we will read it together. Alright, welcome back. The next part says, if you were the captain of a basketball team and could use one more player on your team, would you choose Andre or Noah? Explain your reasoning. So please pause the video. What do you think about that? Okay, welcome back. If you said even though they both have a mean number of baskets, which is 5.25, I would look for the one who is more consistent. So since Noah has a smaller mean absolute deviation, that means most of the time he hits a number of baskets that is close to his average. Good job. Let's move on. Let's talk about Explore Part C. For this slide, what I want you to do is to please pause this video, read the story to yourself, take a look at what this table is asking us to do, and try it on your own. Alright, welcome back. Explore Part C says, an 8th grade student decided to join Andre and Noah and kept track of his scores. His data set is shown here. The mean number of baskets he made is 6. 8th grade student, 6, 5, 4, 7, 6, 5, 7, 8, 5, 6, 5, 8. They want to know the distance from 6. So please pause this video and try to complete this table so that we can use this information in further questions. Okay, welcome back. Now that you've had some time to fill in the table yourself, let's fill it in together. you should have gotten the following numbers in the table: 0, 1, 2, 1, 0, 1, 1, 2, 1, 0, 1, 2. And the way that you get these numbers is by doing a subtraction. You take the distance from 6 and you subtract it from the 8th grade student's data. So essentially 6 minus 6 is 0, 6 minus 5 is 1, 6 minus 4 is 2, 7 minus 6 is 1, and that's how you generate all the numbers in this table. Be mindful of the fact that sometimes you have a number that is greater than 6 in the table. And if you start with 6 minus that number, you're going to get a negative result. Since we're looking at the distance from 6, your answer should never be negative. So what we do instead is we start by putting the bigger number first. So if we know we have to subtract 6, and we know that we're talking about 7, then I would put 7 first and do 7 minus 6, because that will yield in a positive response. Another example is shown here when we have the number 8. I would not do 6 minus 8 because that would result in a negative response. So instead, I'm going to do 8 minus 6 and generate the positive distance from 6, which is 2. All right. With that said, let's move ahead and let's see what else I have for you. So the next thing they want us to do is to calculate the mean absolute deviation. Show your reasoning. So why don't you pause the video and try to calculate this yourself, and then we will talk about what does the process look like. All right, welcome back. So to calculate the MAD, what you need to do is take all of your data and find the distance of that data from the mean. In this case, we did that already in the table. Below here, you can see in the blue the exact calculations that we use to get the numbers that are in the table. 0, 1, 2, 1, 0, 1, 1, 2, 1, 0, 1, 2. Now, in order for you to calculate the MAD, what you need to do is first take all the numbers that you got when you did your subtractions, take all those differences, and you need to add them up. So we're going to add 0, 2, 1, 0, 1, 1, 0, 1, 2, 2, 1, 1. And if you do this, you will get 12 as your sum. Now, what we need to do is look at how many numbers did we actually end up adding. And you will see that we added 12 numbers. So finally, we will do 12 divided by 12, and we will get 1. So essentially, you're finding the mean of the absolute deviation. All right, so with that said, let's move on to part B. Please pause the video, read the part B question to yourself, and then we will do it together. All right, welcome back. Part B says, draw a dot plot to represent his data and mark the location of the mean with a triangle. All right, so how do you actually do this? Well, you'll need to start with a number line. So we're going to move on to the next slide where we have a little bit more space, and we're going to start with a number line. This number line will include the numbers from 0 to 10. You will notice that the mean has a triangle placed right on top of the 6. And then what we're going to do is we're going to look at all of our data. We can see that 4 pops up 1 time. We can see that 5 pops up 4 times. We can see 6 pops up 3 times, 7 twice, and 8 twice. So depending on how many times the number of baskets pops up, we will put that many respective dots in that location. All right, so this is what your dot plot is supposed to look like for Lynn's data. Again, my name is Mr. Cantor. Thank you so much for clicking on this video. I will see you in the next one. Take care for now.